Alright, today we are going to take a look at multiplying decimals. So, take a look at this first problem right here. If Tony has 8 blocks and each block is 1.2 centimeters high and she stacks the blocks, what will be the height of the stack? You probably got the answer of 9.6, but how did you find the answer? Did you use addition and just add them all up? Or did you maybe try and use multiplication and multiply 8 and then add the 2/10 8 times? Both of these ways are a little complicated. So, is there an easier way? Like I said, in this lesson we're going to focus on multiplying decimals as if they were whole numbers and then using an estimation to place the decimal point in the correct spot in the answer. So, say we have calculators and they're on sale for $9.29 each. How much would 5 of them cost? So we're going to set it up the same way that we normally set up any multiplication problem. And we're going to go ahead and do that. 9 times 5 is 45. 2 times 5 is 10. And 9 times 5 is 45 again. So 5, 4, 6, 4. But the answer is not 4,645. So how do we know where to put the decimal point? Well, this one's kind of easy, and we know it's money, so we know we have to have some change, right? So we put the decimal point right here, because it's right there, and we get $46.45. Oh, just kidding. Yeah, no, it goes right there. Okay, so we get $46.45. And if you think about it, if you multiplied 5 times 9, you're going to get 45. Around 45, right? So this would make sense. This answer makes sense. What about 6 multiplied by 3 7/10? Okay, so our decimal point would be right here. 7 times 6 is 42. 3 times 6 is 18. Alright, so our answer is it 222? No. Where's our decimal point go? Right there. And how do we know? Because if we were to multiply the two whole numbers, the 6 and the 3, we would get 18. So we know the number has to be greater than 18, right? Alright, so Devin measures the length of his room by pacing it off. The length of his pace is 2.3 feet, and he counted 14 paces. How are we going to find the length of the room? So an estimation, 2 times 14, we know it has to be a greater number than 28, right? Set up our little Alright, 3 times 1. 3 times 4. 2 times 1. 2 times 4. And we get 322. But like I said earlier, we know it has to be just a little bit greater than 28 because 2 times 14 is 28. So, where would it make sense to put the decimal point? Right here. And we get the answer of 32.2. Why don't you try the next one on your own? Go ahead and pause the video and do it. Whoops. Alright, so, answers. Did you get the correct answer? 8.75. It's done the same way as this. Now taking it into geometry and using our shapes, we have 1.5 centimeters multiplied by 30 centimeters. We know it has to be greater than 30, right? 1 times 30 is 30, but then think of a half. What's half of 30? 15, right? So we use the number model of 1.5 times 30 equals 45. And our area is 45 centimeters squared. So sometimes we don't always have to use our multiplication. We can use what we already know by knowing that 1 times 30 is 30, and that knowing that half of 30 is 15, and being able to add that to 30 to get the answer of 45. This one, on the other hand, is a little more difficult, and we're going to have to use our multiplication chart again. So, using lattice method and multiplying 6 times 15.4, we get the answer of 92.4. And the answer is 92.4 centimeters squared. And in Class Smart, we're going to take a look at multiplying decimals again. So, using the facts that I gave you, hopefully it makes a little more sense now.